In the previous learning objective, we learned that a common ion always decreases the solubility of an insoluble salt. In this learning objective, we're going to determine when and how pH affects the solubility of a salt. This is going to occur if one of the ions in the salt is an acid or a base. So here's an example. This will be a very simplistic example, but we'll expand it to more complicated examples. Magnesium hydroxide is fairly insoluble, but it itself is a base, and we see we have that OH minus. So the anion of this salt is a base. So if we look at that equilibrium, and we just consider Le Chatelier's principle, if we had the system at equilibrium and we went in and we added a base to that system, would we say, thinking about which way the equilibrium would shift, that the solubility of the magnesium hydroxide would increase or the solubility would decrease? Well, if you said that it would decrease, you're correct. Why would it decrease? Well, if you add OH minus, anytime you add something on the right hand side, it'll shift to the left to try to use it up, and you are increasing the solid. That would be a representation of a decrease in solubility. So what is adding a base? Adding a base is the pH would be going up as you add that base, and that would always, that would shift this salt to the left. Okay, so let's do the opposite. Let's add an acid. Now when you add an acid, the H3O plus concentration goes up, but what does the OH minus concentration do? Think about that and then answer the question. Well, if you said it would increase the solubility, you would be correct. Why is that? Well, when the H3O plus goes up by adding an acid, always the OH minus goes down because that product has to equal Kw. If that's going down, then this is being removed. It's decreasing, and you're going to shift it to try to produce more. So in this case, as you decrease the OH minus concentration by adding an acid, or in other words, as the pH goes down, the solubility will increase. Okay, so let's consider another equilibrium. Here is an insoluble salt. For this substance, it might not quite be as obvious as to why the pH would affect the solubility of this salt. But F minus is a conjugate base of a weak acid. Our weak acid, of course, would be HF, and this is the conjugate base of HF. As a base, it will be involved in its own equilibrium. So here it is, F minus in water, which is an aqueous solution, and we end up with the F minus having an OH in its equilibrium. Now this equilibrium here is obviously going to be affected by pH, because as we change the pH, we're changing the amount of OH minus. So let's walk our way through this consideration with some questions. So both of these equilibria are involved. We've got the lead fluoride, an insoluble salt, dissolving, and we have the F minus of that salt undergoing ionization with water. So if we add a base to the solution, what effect will that have on equilibrium number 2? Well, did you say it would shift it to the left? That is correct. If you're adding a base, in other words, as the pH is going up, it's going to shift that second equilibrium to the left. Okay? And that would increase the amount of F minus in solution. Okay, so if you're increasing the amount of F minus in solution, how would the increase of the concentration of F minus affect the first equilibrium? Think about that and answer. Well, did you say that that would shift it to the left? You'd be correct. Okay, so if the F minus is going up, it shifts it to the left. Okay, so what would we say about the solubility of lead fluoride when we add a base and the pH is going up? Okay, that would decrease the solubility. Anytime you get more solid in there than you started with, that's a decrease in solubility. Now we looked at it in terms of adding a base. We looked at it in terms of increasing the pH. And we could go through these equilibria for adding an acid. If you add an acid, that decreases the OH minus. If you decrease the OH minus, that shifts it to the right. That decreases the F minus concentration. Then we go to the first equilibrium. And when we go to the first equilibrium, when the F minus is decreasing, that'll shift it to the right. And if it shifts it to the right, it would increase the solubility. So you could go through and you could think about this for every salt that you come across. But there is a bottom line. And the bottom line is this. If you look at a salt, and the anion is the conjugate base of a weak acid, which we have here. The anion is the conjugate base of the weak acid. Then the solubility would always increase with decreasing pH. In other words, if you added an acid. So anytime you want to increase the solubility of a salt, if you look at the anion and it is the conjugate base of a weak acid, then you would be able to increase the solubility by adding acid. Bringing the pH down will increase the solubility of that insoluble salt.
I want to show you in this demonstration how you can take an insoluble salt and redissolve it by adding an acid and lowering the pH. But first I want to create an insoluble salt. I've got magnesium sulfate in this test tube, and magnesium sulfate is very soluble. But I'm going to add some ammonia. This is going to produce a precipitate of magnesium hydroxide. So I'm going to produce the magnesium hydroxide. Now you can see that the test tube is getting cloudy, and that cloudiness is the formation of the magnesium hydroxide. Since the anion of magnesium hydroxide is the conjugate base of a weak acid, we'll be able to redissolve the magnesium hydroxide by adding an acid. I'm adding hydrochloric acid here. As we lower the pH, the magnesium hydroxide redissolves.